May isang lalaking nagugutom. Napaisip siya kung saan ba bibili ng pagkain, sa McDo ba o Jollibee. At ayon, napili niya ang Jollibee.
Kuya, pabili po nga ng isang large fries.
Sa paglabas niya ng Jollibee, siya ay punong-puno ng kasiyahan. Sa sobra ng kanyang saya, siya'y napatalon. May isa na namang lalaki ang nagugutom. Tulad ni John, si Bobby rin ay nagugutom. Sa paglalakad ni Wilbert, napadaan siya kina Bobby. Biglang niyaya ni Wilbert sina Bobby at John na kumain ng kanyang fries. Dahil dito napasaya ni Wilbert ang kanyang mga kaibigang gutom. Bago nila kainin ang kanilang fries, naisipan ni Wilbert na i-sort ito ayon sa kanilang taas gamit ang bucket sort algorithm. Iginugrupo ni Wilbert ang fries sa tatlong kategorya: small, medium at large. Pagkatapos sa paggrupo, isinort ni Wilbert ang bawat kategorya ayon sa kanilang taas. Nung natapos ni Wilbert ang pag-sort, muli niyang pinagsama-sama ang lahat ng mga grupo upang mabuo ang sorted na fries. Pagkatapos nila sa pag-sort, kinain na nila ang kanilang fries.
Bucket sort is a sorting algorithm that uses the scatter-gather approach. This means that the elements are first scattered into groups called as buckets. The buckets are then sorted individually before being gathered to form the sorted array. To give us an example, let us now try to sort my group members using bucket sort. So first we have to establish all the buckets. So here are my group members. First we have Andre Nadella. We have Kisi Soria. We have Carlo Mingita. We have Jmar Dolorito. And we have Jay Gama. First we have to establish the groups or the buckets. Here are the buckets. These are differentiated according to height. So we have 4 foot 11 to 5 foot 2, 5 foot 3 to 5 foot 5, 5 foot 6 to 5 foot 8, and 5 foot 9 to 5 foot 11. J is a 5 foot 5, so J stays on the second one. Jmar is a 5 foot 7. So Jmar stays on the third. Carlo is a 5 foot 9, so Carlo stays on the last one. PC is a 5 foot 2, she stays on the first one. Lastly, Andre is a 5 foot 4, so he stays on the second one. So once we have all of them sorted into their different buckets, we are now individually sorting each of the buckets. So we are sorting them according to their height, in ascending order. Where is Kisi? She is the only one in her bucket, so she stays as is. And J is first, and here is Andre. But Andre is much smaller than J. So they should be inter. They should be a swap. They should swap places. And only Jmar stays on the third bucket, so he stays there. And we have Carlo on the last bucket, so he stays there. So once the buckets are individually sorted, they are then gathered as one to form the sorted array.
To explain this further, first we separate a set of elements into different groups called buckets, where each bucket represents a specific range of values. The range of values inside each bucket would depend on the distribution of the data in the set or the specific criteria you choose to define the boundaries of the bucket. When the elements of the array are integers, we can calculate the range of values using the formula range is equal to the ceiling value of the maximum number minus the minimum number over the number of buckets. When the elements of the array are floating range values ranging from 0 to 1, we can create 10 buckets which have the values of 0 to 9 and will correspond to the 10th digit of a float. For example, in this array, we create 10 buckets where each bucket would have a range of 10. Since by using the formula, we get 96 minus 4 over 10, we get 9.2, and by getting the ceiling value of that value, we have 10. In the first bucket, we have a range of 0 to 9, where each value that falls into that range goes into that bucket, and we do the same thing for the other buckets as well. Then after distributing each element to their corresponding bucket, we now sort each bucket using any sorting algorithm that we like. And finally, the buckets are combined into an ordered fashion to form this sorted set. To give you a step-by-step visualization, we have Casey and Jmar.
So another real-life example of bucket sorting, which is very easy to do, is sorting a deck of cards. First, we're going to group them based on their color. We have our two colors, which is the red and black. Next, we're going to group them based on their suits. We have the heart, the diamond, the clover, and the spade. After that, we're going to group them based on their number. So I have here 20 different types of cards, and my friend UJ is going to help me sort them out.
The bucket sort algorithm works best in situations where data is evenly distributed, where each bucket contains roughly the same amount of values. In this situation, the bucket sort algorithm would perform better than the algorithms like quicksort and merge sort. It also does less comparisons, making it more efficient than other algorithms. However, in some situations, the bucket sort algorithm might not be the best options. When data is highly skewed, some buckets might have more values while others might have less or none. This might cause an inefficient sorting within buckets. With a large range of data, there might be more buckets needed to be created, which can cause more memory to be consumed. In the best case scenario, where each bucket would have roughly or would have the same amount of values, the time complexity would be O of n. As for the worst case scenario, where every element goes into one single bucket, the time complexity would depend on the sorting algorithm that we would be using. So it can range from O(n) squared to O(n) log n. And as for the space complexity, it would have a space complexity of O(n) plus k, where n represents the number of values and k would be the number of buckets that were created.
So, bucket sort. So to show you how do we do the algorithm bucket sort, we're going to show you the output. So for case 1, we have an unsorted list of array, and after we sort it all out. And how did we sort it out? Now let me show you. So first we use a bucket method, and we create empty buckets. And to get the range of each empty buckets, we use the formula max minus min divided by the number of buckets. If we got the range for each bucket, we add elements to it. And after we add the elements to it, we sort each bucket using collection.sort, which is the same as merge sort. And then we gather all the buckets into one sorted array. As you can see, this is that array. And then we printed out the time complexity, so we can see how long it takes. Now for the second case, which is float, we use the bucket float. So we create empty buckets, and to compute for the range of values of each bucket, instead of using the max min formula, we use index instead. And then we sort the elements in each bucket and gather it into one sorted array.